Last one for target 6C, 6C.4. I can solve real-world problems by drawing a diagram and applying the properties of similar triangles. Alright, so looking at our first example. I don't know why we're starting with example 9, but whatever. At a certain time of day, a 1.8 meter tall person standing next to the Washington Monument casts a 0.7 meter shadow. At the same time, the Washington Monument casts a 65.8 meter shadow. How tall is the Washington Monument? Okay. So the first thing I'm going to do is just draw a diagram. I have a person and their shadows on the ground. Okay, I'm not going to draw something crazy even. Okay, and then I have this make-believe line here. Okay, so these situations are still right triangles. Okay, it's kind of, you have to pretend there's a line going from the top of the person's head to the top of their shadow. Okay, and that gives you a triangle so that you can use these proportions. So always just draw a right triangle. Okay. So the person is 1.8 meters tall, and they cast a 0.7 meter shadow. Then I have my Washington Monument. Top of the Washington Monument to the top of its shadow. It casts a 65.8 meter shadow. How tall is it? So I'm going to put my x, my variable, where its height is. Okay. This is my diagram. Now set up a proportion. I'm still going to start with my variable. X over, right, 1.8. Right, they're both the height. Then I have to go back to my first triangle, 65.8 over 0.7. They're both the shadow. Okay. So height over height, shadow equals shadow over shadow. Once I have that set up, cross multiply. X times 0.7 equals 1.8 times 65.8. X times 0.7 is 0.7x equals 1.8 times 65.8. It's 118.44. Then technically there's multiplication here, right? So I'm dividing both sides by 0.7. 0.7 divided by 0.7, right, cancels out, it's just 1. So 1x equals 118.44 divided by 0.7. And I get 169.2 meters. For these, we have to use units, okay? And that's it. Easy enough. It's just like what we've been doing. Looking at example 10. A 6-foot tall tent is standing. A 6-foot tall tent standing next to a cardboard box casts a 9-foot shadow. The cardboard box casts a shadow that is 6 feet long. Then how tall is it? Okay. So my tent is 6 feet tall and has a shadow of 9 feet. It's next to a box. Right? The shadow is 6 feet. How tall is it? Okay. So doing the same thing, height over height. So x over 6 from the height here is going to equal height over height, shadow over shadow. So 6 over, right, my other shadow is 9. Once I have that set up, all I am doing is my cross multiplication. X times 9 equals 6 times 6. 9x equals 6 times 6 is 36. I'm going to divide both sides by 9. X equals 4, and my unit is feet. All right, last example here. Oh my God. A telephone booth that is 8 feet tall casts a shadow that is 4 feet long. 8 feet tall telephone booth, 4 feet long shadow. Triangle. Find the height of a lawn ornament that casts a 2 feet shadow. So I have my lawn ornament. I don't know what the height is, but its shadow is 2 feet. Okay. So I have, right, starting with our variable, height over height, so x over 8 has to equal, then shadow over shadow. 2 over, right, my other shadow is 4. Once I have that equation set up, all I am doing is cross multiplying. So 4 times x, or x times 4, either one. 8 times 2. I have 4x equals 8 times 2 is 16. Divide both sides by 4. 16 divided by 4 is 4. Again, this is feet. So x equals 4 feet. All right, that's it for C4. Go ahead and work on the activity.